Okay, mic check, 1, 2, 3. You guys can hear me well, right? So my name's Robert Pumpurs, and I'm going to be talking about how to stop teaching your agents to do the same work twice and just do it once. More specifically, writing code for LLMs, with LLMs, and the product that we've built in the company that I work at. So a little bit about who I am. I'm an open source enthusiast. I've been a software engineer for about 8 years. 5 years in doing blockchain stuff, mostly peer-to-peer networking, cross-chain bridges, consensus engines, and basically blockchain infrastructure work. I have some hobbies which involve high-frequency trading bots, some arbitrage stuff, and some performance-optimized things which I kind of enjoy. And nowadays, I'm building Rote at Modiqo AI, which is going to be the product placement of this presentation. So, I also have a blog, which is blog.pumpurlabs.com. You can scan the code. I write about software engineering, about LLM-assisted development, and a bunch of other stuff that you may find interesting, which is also going to be referenced in this talk. At the end, there will be a bunch of QR codes and links, so you'll be able to scan them there as well. Okay, nowadays, let's imagine a typical LLM-assisted developer, which is a person who uses Claude, Codex, Pi, Kimi Code, OpenCode, any of these tools, right? The general workflow is that now these LLMs, they're so good at producing code that it just wastes your time to sit there and wait for them to spin up like their thinking process and then write the code and so on and so forth once you write the prompt, right? So generally what people are doing is splitting out the work into multiple parallel threads. So you have one chat, second chat, third chat, fourth chat, all of them going on at the same time. One of them pings you, you're like, okay, let's jump back there and just basically respond to all of these agent chats. In a code base that typically involves spinning up a bunch of Git work trees. So you have 7 to 8 different work trees with a bunch of agents doing a bunch of parallel different work. This typical engineer probably has a bunch of MCP servers, a bunch of skills to help them manage this different workload and so on and so forth. As you can see, there's a screenshot of my active Git work trees over here, and there's like dozens of them, right? So here's a typical prompt. Look at all the current Git work trees, check the state of the PRs for each of them, and if the PR is already merged, give me a list of work trees that can be safely deleted, right? Because I had a laptop that had 500 gigabytes of SSD space and the target folder kept eating my hard drive and my computer kept crashing, right? Oh, that's bad. Okay, generally there was supposed to be a demo over here. Let's see. Let's play it like this. No, don't know what happened there previously. So here I paste in the prompt. The agent is going to look at the Git work trees. It is going to try to figure out which ones can be safely deleted because their PRs have been merged, and basically does a bunch of work. And at the end here, it gives me the result. Okay. So what's the issue over here? Oh, now it works. Great. The agent succeeded, and then we threw away the workflow, right? The agent did all of the thinking process, doing all of the tool calls, communicating with GitHub, and so on and so forth, and then it gave you this one-off result, and you can never re-interact with it again. So here's like basically a diagram of what I just said. You send a routine request because you're out of hard drive space. The agent figures out which work trees can be deleted, gives you the result, and if you're like clever, maybe you will try creating a skillmd file for your LLM to basically help you in the future to do this routine task. But then you end up with the result of a bunch of scattered skillmd files that are just eating up your context even more. And the thing is, the context window of your LLM agents, it is not designed to basically eat all of this information, right? Because the context window contains information like your user intent, tool descriptions, and MCP server definitions, memories that get injected at runtime by your harness, and basically all of this other stuff. And the more stuff you basically plumb into your LLM context, the worse it's going to give you the results. For example, here's a diagram of like that basically shows that AI accuracy drops as the context increases, right? So the ability for the LLM to remember what you asked previously just becomes worse the more you talk to it, right? So you need to be very careful about the stuff that you actually put in there. There are tools obviously out there like Human Layer, desktop app, there's superpower skills, there's also these grill me skills, and all these other things that basically are kind of designed for you to like produce better results, but they're like squeezing out performance, not reducing token spend, and you just like still end up spending a bunch of tokens to do the repetitive task. So at the end, you get non-determinism, you get hard to share behavior, your context grows, workloads get buried in a bunch of retry loops and skillmd files and etc. So the tool that we have built at Modiqo is called Rote. And in one sentence, it is a tool for building deterministic, replayable executables that your agent produces just by you talking to your agent, right? What you basically achieve at the end is your agent can do a task, you can then share this task with your team, you can share this workflow with your team, and then your agent can reuse the same workflow for any other future encounter. Typically, the workflow is that you talk to your agent does the work, we capture the traces of your agent, we extract the meaningful information outside of it, we can generate an executable, and then any single time you request your agent to do the same thing, it is going to reuse the executable instead of trying to figure out how to chain up all the tool calls and waste tokens that you already had wasted once to generate the executable. So, taking the same demo of asking which work trees can be safely deleted on the computer with using our tool, right? So exactly the same scenario here, just like using the Claude extension. So same prompt, at the beginning I just put /rote to invoke our skill, and the agent is going to start using our tool to achieve the same task. Look at all the Git work trees, communicate with GitHub, see if the PR, like the branch has a PR that has been merged, and then like report back if it can be safely deleted. So here the agent is doing all the number crunching, doing all the requests. Here's just like a visualization via our VS Code extension of all the requests that it's making, how much tokens are being spent, and everything else that we're capturing basically from the live trace as the agent is doing the necessary task. And soon enough, here we have the result at the end. The agent prompt, I can save this as a reusable rote flow for the next time. Save yes. I'm just going to say yes because I want to run this same thing every once in a while when my target folders have exceeded my disk capacity on my computer. Right, so let's see, how long does the demo go on? So yeah, another visualization of all the requests that are going in as the agent and the tool are producing the executable for you. Some more visualizations from our extension where we can see like how many tokens are being spent, how the tool calls are looking, and so on and so forth. So here, the flow has been created. I'm just for the demonstrative purposes, I am taking the same prompt that I pasted, like wrote in previously, and putting it in a new chat. And just in a few tool calls, the agent is going to completely able to reproduce the same result as previously, just by sending a request to our tool. So here Claude is basically making all the tool calls. And here we have the result in fraction of the token spend that was needed in the very first place. Right, here's another demo. You can scan the QR code to play around with it as well. And this is something that I actually recorded just yesterday. I got a computer upgrade, but still I had more than 1 terabyte of target files on my computer across like 50 work trees. So again, I need a routine cleanup again. And the prompt here is like very simple. Just delete these work trees that I have on my computer, and at the end give me the flow. It produced the flow, and I just asked it how to run it with args. And now it's giving me a command that I can execute manually, but at the very same time, instead of executing it manually, I can just ask my agent to do the task the next time, and it is going to able to find this executable and run it on its own without wasting the tokens. Here we see the results and like what was cleaned. So as you saw, the model essentially is, how you think about this like as a diagram, is that we have the model, which is from big AI labs, OpenAI, Anthropic, Kimi. They tell the harness what the intent is of what they want to achieve. Then the harness performs a tool call to Rote, and then Rote is like our CLI that we provide. It basically captures the evidence of like all the information that the intent was trying to achieve, or it then synthesizes a reusable workflow that it can reuse in the future to achieve the desired intent. So now I'm going to talk about more how is Rote actually built with agents as first-class consumers. As you can see, it is a CLI, but we are not the intended users of the CLI. It is our agents, it is our LLMs that are using the tool. And a few things to get straight here is that the prompt that you write is not a skill, and it is not a tool, and it is not a workflow. And essentially, all of these are different concerns in the land of agentic engineering, and we basically need to understand like what we're looking at. So prompt is the thing that you write. Skill is something that you or somebody else has written in a prompt style that gets injected into the harness for inference reasons. Tool is something that the harness can call to achieve, let's say, bash call, Python call, web lookup, whatever. Those are tool calls. MCP is in a server that basically allows your harness to communicate to an external endpoint to provide you different tool calls. And in scope of Rote, we have this concept of plays or flows, as we tend to call them, which is like reviewed executable procedure. So when designing Rote, one of the conversations was whether we go with CLI or an MCP approach. As you may know, like a bunch of different services like GitHub, PostHog, whatever, all of them offer MCP servers, right? But what does it actually mean? It means if you install an MCP server on your computer and you spin up a Claude or Codex, these MCP tool definitions actually eat up your context, right? It means that you will get worse results the more MCP servers you have. For example, here we have like an example, like GitHub MCP server defines 35 tool calls, which are again just eating up your context even if you don't use all of them. Whereas if you go with the CLI approach, which is what we did with Rote, you don't have to worry about the context being eaten up because it is just a single Rote CLI tool call, right? And there's nothing more attached to it. Another thing that we do in Rote is runtime agent steering. So instead of expressing everything out in Markdown files, the skillmd files of how to use this tool, the tool itself is self-correcting and telling the agent of how to properly use it. And this is like just output of how it actually looks like. So we have write guidance, road grammar, and et cetera, and how to properly interpret it. As you can see, like we're using this technique of using these at symbols, like at result, at status, at next, which are basically, you can imagine it as like compiler output, if you know, like you're kind of referencing symbols. And LLMs are surprisingly good at actually following these instructions if you actually tell them how they should interpret these kind of special characters, because it's just like they're trying to predict the next token in line, and if you explain to them how they must interpret these tokens, then they're like surprisingly good. So here's a short demonstration of like how an LLM actually interacts with Rote, and I'm just like manually writing in these commands. So all of this output with these hint and what's the state and so on and so forth, they're like kind of engineered in a way to make the agent better understand the intent of what you're trying to achieve and how to interpret the output. So yeah, this is how it looks like. Adapter list, etc., etc. Yeah, but essentially, yeah, we're just using these symbols to guide the agent at runtime of what are the next steps. So the agent does not need to know everything up front. As it's progressing through the CLI API, it is discovering the next items it needs to do. And yeah, as I said, help is runtime guidance. Our CLI captures the intent of what the agent is trying to do. It creates structured output, and then it guides the agent of how to proceed further upon until it basically goes inside this loop, and then the goal gets achieved. Yeah. So another thing that we have is this concept of adapters, which is a replacement for your MCP servers and a bunch of these external API things that you may have. So as I said previously, if you have GitHub MCP installed, Posthog MCP installed, a bunch of other stuff, you're just like wasting your context space, which is going to give you worse results. So Rote CLI basically has this idea that you can install MCP servers which are hidden behind the Rote CLI API, meaning that you don't waste your context space and you can install thousands of MCP servers and you can adapt any existing API, GraphQL API, anything else within the Rote progressive disclosure. And then when you're basically talking to your agent, get my GitHub issues, right? Your agent is going to talk to Rote CLI, get my GitHub issues, it's just going to pass it further on, and Rote is going to do semantic indexing of the tools that it has available and present them to the agent, meaning it is, again, progressive disclosure, trying to minimize context waste and trying to achieve the goal with the least amount of steps desired to actually achieve it. Here is a screenshot from our VS Code extension. We have this adapters page where you can install this concept of adapters, which are like these API abstractions that we have, and they also follow the same approach of at symbols that we use in the code base. So generally, when you're talking to your agent, there's these two concepts. One is the context itself, which is every single token that comes out and that goes in. It's an ephemeral cache of what is actually happening in the conversation. But as the agent is using our Rote CLI tool, we have this ephemeral cache, which is saved between the sessions, which allows us to basically understand the intent of what the agent is trying to do during longer progressive tasks. And then like this information is used to generate the executables at the end. We tend to call this process of generating the executable crystallization. And when all of this information of how the Rote CLI is being used to achieve the task, it is used to generate a directed acyclic graph, so basically a DAG, of how all of the steps intervene with one another and how they depend on each other. And then at the end, we can generate the code that basically achieves the same task just by observing from the traces of how the agent actually operated. This is how a typical executable looks at the end. It's basically a manifest expression and a TypeScript display state. That's the best way of putting it. So over here we have the steps, that's the DAG that gets executed by our runtime. And then we have the presentation layer, which is showing this information to the agent in a meaningful way that it can reuse it in the future. Another thing is that not only we support random arbitrary APIs that you can put there, but we also support browser and CLI automations, meaning that you can fetch something from GitHub, you can pass it through a shell script locally, you can, I don't know, open up the browser and create a new issue via the tool just opening a new issue manually, right? All of this combines into the same DAG that we can generate these executables from that you can then share with your team and run on your own. So here's going to be the crown jewel demo, which is using the browser, go to YouTube, and click on the first recommended video, use YouTube DLP CLI to download the audio from the first recommended video, use YAP CLI to generate transcripts, use LM Studio with an LLM to generate a summary of the video, save this as a play, right? We're gonna go through all of this pipeline. I really hope the video works. Right, and here, same prompt that I just described. And you just express the intent to the agent, and then it's going to spin up and do its work. Right, here's prompting me of what do I want to use in LM Studio. Like these tools like LM Studio, YAP, and etc. I had set them up previously on my computer, right? So those are pre-existing. But now the agent is already navigating to YouTube, as you can see there on the side. Like you can see my recommendations. And the agent is now exploring the surface of the browser. It's clicking on a video, like it found advertisements, and it's like getting confused by that because such is life. Then the agent is basically going into loops, trying to figure out what's going on, how to navigate the website. It's refreshing the website because as it's exploring it, it's also refreshing it and seeing if how stuff works. Turns out browser automation is extremely difficult, as you may have imagined. And at the end, here we have the code generated. And now, in this very next video, I am taking the generated code and I am executing it, right? That's the same flow that was just generated in the previous one. And here it automatically opens up YouTube, clicks on the first recommended video. It's downloading the audio. And now it's going to, oh, it's already transcribing it. And in a second, it's going to pass it to LM Studio for inference of what's going on there. So all of these steps were previously done by the agent. The agent was achieving this output in the desired state, right? Now it is just an executable. There's zero inference going on. The intent just was expressed once and the agent did it. Right, now, oh, it's passing the chunks to LM Studio because I was using a small model. It could not take everything in one go. But here is the output from LM Studio, right? So that's the inference step that I was running like locally. And now this is just a generic executable. I can, assuming a friend of mine has the same tools, I can just like share this thing with him and he can like run it on his own machine. We also have a built-in secrets store because a bunch of APIs out there require auth tokens, OAuth tokens, and we basically manage all of that for you if you choose to set it up, because if you can authenticate to PostHog or Axiom or these other kind of, or Datadog, you can start aggregating data from your services. So instead of like talking to your agent, hey, how is my Discord bot doing like during the last 2 days, right? And every single time you ask your agent to fetch this data, now you can just like generate an executable and it's going to give you a report. And you can put it in your CI and it will work with zero inference costs. Another thing, while building such a tool, we need to keep in mind that skills are code as well. And we ship quite a few skills. So we have runtime guidance and we have skills that we ship with the agent that basically work as a state machine expressing to the agent of, oh, you are in this stage, now we need to move to the next stage, invoke the next skill in line, then invoke the next skill in line, call this Rote CLI tool, and basically it's an ecosystem of its own that is actually extremely difficult to manage and get it right. So while developing something like this, we are obviously eating our own dog food and using the CLI ourselves every single day, and we're noticing, oh, this is wrong, that doesn't work. So every single time when we notice these things, they become like mini incident reports, and we either patch the skills, we patch the runtime guidance, or we make some other necessary changes that are needed there. We also test whether agents get dumber, because to make sure that a tool like this actually works, it requires testing harnesses, it requires testing different models, different scenarios, long horizon, compaction, right? You're talking to your agent, it hits the context wall, it needs to compact. After compaction, will it actually be able to continue with the task that you actually described it with, right? So these are all a bunch of different scenarios, and we're trying to optimize our skills and runtime guidance to make it actually work and pass our scenarios that we have. So a question. Who is this tool for? This tool is generally for people that are, let's say, owners of a small company. You rely on your team to express some domain knowledge. Let's say you have a very skilled worker who's using agents day to day, not necessarily software engineering, but general knowledge work, working with Excels, with external data, marketing agencies, and so on and so forth. And when this person leaves, this person takes all of the knowledge with him, right? You have lost a very crucial person from your company. But if this person uses this tool, then this person's workflows of where he fetches this information, how does he produce the marketing content, what are the APIs that he talks to, how does he create like Facebook ads or whatever, this information can persist in the company, right? Because we basically generate these executables that any other future like employee can come and pick up with and reuse. So you basically facilitate usage of workflows within a team. This tool is also for people that pay for tokens. So generally, you or I, we're probably on Claude Max or Codex Max subscriptions and like getting a bunch of subsidized tokens. And in that case, yeah, probably this tool is not the right fit for you because you can just like spend how many tokens you want to. But if you're in a large enterprise that actually pays per token, like it can be extremely, extremely expensive. And this tool basically helps you save on token spend. So next chapter of this topic is building in Rust with agents. Because this tool is actually fully built in Rust. It has like 500,000 lines of Rust code in it. Large chunk of it, probably half of it, is just testing infrastructure to make sure that it does not shit itself. So yeah, these are some takeaways that we've gathered from like months of building this tool. So what agents do well? Agents are extremely well at exploring unfamiliar code, especially code that you have not written yourself. They are also very good at producing plausible patches, code that looks reasonable. They're great at generating boilerplate fixtures, migrations, testing infrastructure, and a bunch of other stuff that would usually just take a lot of time to write out. And they accelerate mechanical work, and surprisingly, they're also very good at brainstorming. So if you cannot like figure out how to do something or just you want external opinions, then agents are usually great at giving you those. Agents will also ship slop. Leave them for too long unattained, and you will get a PR like this. It actually got merged, and there's a very good reason why. I will tell you guys later. But this is the real PR that sadly I produced, and my colleagues were reviewing. Another thing with agents is that they tend to overthink. Here I had a scenario where I had 3 pull requests stacked on GitHub, and I thought, okay guys, there's some issues. I'm just going to run my agent in a loop of like, fix all the security vulnerabilities, then do another round of review, basically having a loop of the agents until it achieves the goal of everything has been fixed. End result was 26 PRs, right? That happened just by leaving this agent like chat open for like 2 days, letting it cook while I was doing some other stuff in the meantime that were at that point more meaningful. So that's the end result. That is unreviewable, and you need to be careful to not ship PRs like that. And that is basically, don't leave your agents unattained, and be careful about which models you use. For example, here I was using GPT-5.6 Sol on extra high inference. What does it mean? GPT-5.6 Sol is, I don't know how to put it, it's like very autistic in a way where you tell it what to do and it will just force its way through until it achieves the goal. It will not actually stop and question whether the thing it's doing is actually correct or should it take a different approach. So I had asked it, keep running in the loop, it's like using the /goal command until you achieve the result. And it was running in the loop, and it kept finding security issues because these agents are extremely good at finding security vulnerabilities, right? Such is the reality, so be careful about what you wish for. Another thing, while managing slop, is you need to understand that prompt engineering is not exactly the same thing as context engineering. Prompt is your intent, as I expressed previously, and context is everything else that the agent already knows about, right? So you need to be careful about writing your prompts so they actually produce the information in the context that will help the agent achieve the end result. What does it exactly mean? As I said previously, context is a shared budget, meaning that you need to be careful about not introducing crap inside of it, right? So everything that is inside the context of your agent chat is basically pre-generation for your next token to be generated, right? If you have a bunch of bad guidance in there or bunch of unnecessary stuff that you were talking about, then the agent is going to go off the rails and start writing other slop code that you will be confused about why is it there. And it's mostly because you were just a bad prompt engineer and bad at keeping your context empty enough. So as I had written here, everything visible competes for attention. Incorrect information is worse. Missing information is bad. The noisy information is still harmful because it's going to confuse the agent when it's going to generate the tokens. Another thing is use sub-agents. Essentially, if there is small piece of scoped work that a top-level agent can delegate to these smaller agents. And they were just going to return back with like short description of what was done and what was achieved, and that will keep the main context clean enough. But yeah, spawning subagents also costs tokens, because spawning a subagent is a tool call. It is producing a prompt, and that it is inferring the prompt coming back from the agent. So it is not free, right? If you are like running out of your context in your current session, you decide to spawn out an agent, you will most likely hit the compaction of your orchestrator agent at that point. Another useful technique is using workflows. So this is something that Claude has as Ultra Code. Codex has it called Ultra. Pi itself has PyHarness has its own like open source ecosystem, which is actually very bad from personal experience. And workflows can be useful when you want to achieve very large scoped work that is extremely difficult to express in a single session. For example, bun rewrite in Rust. So bun initially was in Zig, and the CEO of the company that owns bun decided to rewrite it in Rust, and he used workflows in Claude Code running for, if I remember in their blog post, it was for 11 days, 64 Claude code sessions running at the same time, rewriting the whole code base from Zig to Rust. And at the end, they achieved the result. So if you are in a place where you need to rewrite something as huge as bun from Zig to Rust, then yeah, this is a thing that you can use. For smaller things, probably not necessary. So a practical lesson here is something that is called like this research plan implement loop, which is when you want to develop a feature, get a markdown artifact from the research. Then you start a new agent session, you feed in the markdown as the initial context, and then you try to achieve a plan. Then you produce a markdown of that plan, and then that plan goes into a new session of, hey, we need to implement this something, and only then you get to the part of actually implementing the piece of code. This way, all of the research noise does not pollute your context. This way, the planning phase does not pollute your context, and you will be able to just achieve less slop at the end, because that is fundamentally what we're trying to achieve when building with agents. So this is like an example of how it looks like. This is from a side project of mine. You can use something like Superpowers plugin, the skill set that basically takes care of this for you. Another thing when scoping your work is try to scope for vertical slices, because if you just open your like Claude Code and you tell your agent, hey, I want to design a very nice API that abstracts over XYZ, it is going to like make the best looking Rust code you have ever seen with amazing abstractions. Well, obviously if you guide it with that way, that will be completely unused by the rest of your code base. Because the agent will think, oh, this is my goal. It needs to think about, oh, what are all the possible use cases of how somebody can use my library, right? It is completely unnecessary, and you will be just inflating your code base with a bunch of slop. And that way, if you're designing a feature, the best way is think about what is the fundamental bottom layer and what is the top level layer of where the interaction will come from, and just scope out the minimal slice. Because the agent will happily write more code than it needs to, and at the end, who will be maintaining it? You won't be able to maintain it. You will be wasting more tokens to maintain it in the future, right? So just make the smart decision from the beginning. Generally, so our workflow is when we're building new features, we're going with this research plan implement loop because that achieves the least amount of slop, at least in our experience. And but if you have some stuff like, oh, I need to rebase a PR and like resolve a bunch of merge conflicts and so on and so forth, those can be just one-off sessions. Just open a new Claude instance, tell it the intent that you need to do, and it will be good enough. Because this research plan implement, it just takes a long time to get it right. Another good recommendation is Human Layer desktop app. I don't know if you guys have like been following this, but Human Layer for a long time have been advocating for shipping less slop, and they have this really nice desktop app which hooks up with your Claude subscription or your Codex subscription, and it handles this research plan implement loop very, very well, and it will produce these markdown files. You can paste comments in these markdown files that the agent can then respond to basically guide the whole end result in a way where it is not going to be completely crap. So this tool is completely for free. It's a big recommendation. Another thing, when you are in a team where everybody in the team is actually using agents to write code, you will notice a situation that nobody can review the code anymore. Such is the sad reality of things, because code got cheap and understanding it became expensive. So before you start vibe coding and before you start like writing 20,000 line code diffs, you need to get everybody on the team aligned. And because if you just like present your teammates, hey guys, I have this huge ass PR, go review it. Nobody will be able to review it. And the expensive part is you need to bring everybody on board of what's actually being built before it is being built. Because back in the day, I don't know, like 3 years ago, like how many lines of code were you able to produce in a day, right? My cap was around like 700 lines of code of well-tested Rust code that I was happy with shipping, right? And now the metric is different. Like I'm shipping 4,000 lines of code a day, and the rest of my colleagues as well. So understanding the code is no longer, it's a completely different ball game, right? So the abstraction of team alignment needs to come before you actually start writing the code. So here's an example of our code base. So as we were like building out Rote with this runtime guidance, with these CLI inference of like trying to guide the agent in different ways and tuning our skills and so on and so forth, we basically were not using clap in Rust. We were shipping our own runtime parser because we were making a bunch of experiments, and clap was just not cutting it for us because it was too restrictive of what we wanted to do. As an end result, we had 500 commands with manual parsing and manually render help pages. They were starting to get outdated, and it was slop. It was slop code, right? So we had a pretty difficult migration actually, because even though this was slop code, it was optimized for agent usage, meaning the way how it worked extremely well for agents to actually follow it, and we did not want to break it. So what we ended up doing is we had the migration path of getting these 500 CLI commands of custom parsers into something that we owned ourselves. We had like CSV middleman layers and a bunch of other stuff to basically achieve this migration. And here's like a screenshot of LLM like describing this thing, like one CLI described 3 times and force 0, like just roasting like this whole setup because it was fundamentally bad. And what we achieved at the end is we reinvented clap at home. And we basically do our own build time command generation with like all of the help and everything else, and validating that the commands actually exist. Because there's a potential drift, right? If you have skills, you have runtime guidance, and you have your CLI surface, if you change the CLI surface but forget to change one of the other thousands of files that you have, then essentially you have drift that is unenforceable. So we're like trying really hard to make sure that this does not happen in the code base. So yeah, this is a diagram of what I just said. Another thing in the code base is starting with like using this goal, like /goal, which will basically make the agent. So if you're using something like Codex or Cloud Code for Pi, there's an extension that does this. You can basically give it this prompt and it is going to go in a loop. As I said, this is the bad example, the screenshot that I showed previously, how 3 PRs became like 26. That is when you leave it unattained with a very generic goal, and the agent is going to like produce very unparsable things for you. But as in this example of migrating our CLI from slop code to something that is build time generated and everything else, it's largely a mechanical refactor. And that is the one that produced that 20,000 lines of code PR, because it was /goal refactor this blah 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 in this format with X, Y, and Z. And the agent just kept going in the loop for about a day, and at the end we had a PR which was like a largely mechanical refactor of going from slop-based version to actually production viable version. Another thing that we utilize in the code base is new types, type state, this pattern that code that changes together lives together, and getting rid of mod RS files if possible. So basically, following proper types in our code base helps the agents actually understand the domain better, because no longer are you just like procedurally guiding, like writing the code like as in the C or C++ days, more like C days, but now you can actually express things in types and like enforce in domain domain level abstractions, and etc. And it basically helps the agent understand your intent, because most of the cases, if the intent is clear for you as a human, it is clear for the agent as well. Just imagine if a junior developer comes, joins the team, can he understand what the business is trying to achieve? And that's what you need to express in your types. The thing about the mod RS, you may be questioning, why do you want to get rid of it? Imagine your agent runs rib-grep for mod RS files, right? All of those files are going to like show up there, or tries to run find for like specific thing. The thing is, you want to have your files be domain specific, so that the agent, when it's trying to like search the code base, it does not hit random things that are completely unrelated. So if you have like, I don't know, 100 mod RS files in the code base, it's going to make the grepping harder for the agent to actually find the things that it needs. So instead, just like create a module with the modern module naming that Rust has. Another thing, so this is more of a lesson of like building a CLI. So this is a software that escapes your runtime. Imagine if you're just doing like web services. When you deploy a web service, you have a database, you migrate the database, you deploy the new version of your web service to your EC2 instance or Kubernetes cluster or whatever, but you basically own everything. You own the data that it stores, and you own everything else. But a CLI, on the other hand, it is a tool that does not run on the machines that you own. So there's like a lot of similarity with like blockchain, right? You write code that is not running on your machines, but you still need to ensure that this code is able to communicate with either other instances or with some common service. So essentially, all of the things that you build, you need to think about keeping it versioned, right? If something touches the data, or like manifest JSON on your computer, or like a config file, or et cetera, it needs to be versioned, because you are going to change the API sooner or later, and you need to have a migration plan. The other option is you just have a huge ass struct which has a bunch of options inside of it, and magically at runtime you try to figure out in what version the tool is depending on which fields are set in this like struct. It's going to be a mess. So instead, just create an enum v1, v2, v3 with like the actual proper version structs inside of it, and it is going to make your life 100 times more easier. Another thing is that LLMs keep improving all the time. So if you produced a lot of code with models from like 6 months ago, that code is going to be absolute shit compared to the ones that the models can produce now. And you're probably going to spend some tokens refactoring older code. And this is just something you need to be aware of. As agents keep improving and these models keep improving and they're better at reasoning and better producing code that does not look like absolute ass, you may have to do less context engineering because the models are getting smarter, but still it does not eliminate the fact that you need to be aware of what they're producing and how to best tune them. Another best practice is using the tree command in Py. In Codex and Cloud Code, they have the double escape, just tap that to rewind your context. So if you're basically chatting with your agent and you see that it's basically going in the wrong direction, just double tap space, rewind your conversation, keep the context clean, and guide the agent in the correct way where you wanted to produce the code that's needed. Another practical example that we had in the code base is allowing the agent to just fully own our testing infrastructure. So we had a situation where we use Supabase, where we use Docker and everything else. And if you are producing a lot of code, then it's going to be like very difficult for you to run integration tests because they just need to spin up like a bunch of Docker containers and everything else. And then you just run them serially and then you wait for like 30 minutes for your test suite to run. So what I did is just let the agent completely own our testing infrastructure and building a pretty cool test lane setup where you can detect how much RAM you have, how much CPU you have on your machine, spin up the necessary Docker instances at runtime, and we're using Cargo Next Test, which basically it has this like experimental feature where you can like hook some crooks and nannies in there, and then you can like delegate those running tests to one of those test lanes, and then as an end result, you can run a bunch of tests in parallel instead of having to wait serially for them to complete. And back in the day, writing this by hand would have been like 2 weeks worth of effort, 3 weeks, who knows? Like, there's a lot of code that went into like producing something like that. But now it's just like a background task. It's a thing I can just put on the back burner. I know it's going to be done. Make sure that it works properly and the team can progress further on. CI bill goes down and everything else becomes nicer. So try to find these kind of things in your daily workflows where you can actually leverage the low cost of having back burner tasks and making agents own them. So on this question, what is safe to generate? With LLMs, primarily unit tests are a very simple thing that you can generate and fully own, and that is completely fine. With proper context management, you can generate basically everything. I have this screenshot from Theo from YouTube. He had like explanation of this, which is generate everything except where people could die. You know, don't generate like medical equipment code or stuff like that. But in majority of the cases, most things are safe to generate, but you can deploy a new version and nobody will be hurt. Unless you work in banking or finance sector, then be more careful as well. Right. Because we're running quite low on time, I have few demos here, but I think I will skip them. But I will just like quickly glance through. So here's like a thing that we have, fetching external statuses, which is again just like Rote was able to generate all of this, fetch whether Cloudflare is up, Slack is up, OpenAI is up, and so on and so forth, and give you a report. So that's a cool thing. So final line is do your best to not ship slop. Rust helps, but no ground is sacred for agents. They will do their best to destroy your code base, so be careful. It's a power that requires ability to wield it. Another ask is go and try out Rote. So that's our tool, free to use. I would be happy if you guys gave me your opinion on it. Right, so this is the final slide. Here is the QR code for the website. We're doing a bit of a rebranding. So we have the old website. You can visit that, but this is the new one, work in progress. That's the teaser for you guys if you want to give me an opinion. That's the command to install the tool. And at the bottom is also my website where you can find all of my connections on LinkedIn, x.com, and etc. So yeah, that's it. Thank you guys.
Do you have any questions? Yeah. So I'm here. So first one.
I was wondering because like you have this at signs that you use in the like description of the system. I guess you have something that processes it, right? So my question is, what happens if one of the steps that the AI agent generates uses those at sign in the first, like in the beginning of the line? Would it not conflict with whatever you use, or do you somehow escape it?
We escape it. So essentially those at symbols and everything else, that is runtime guidance for the agent. So the agent is using the CLI, so it's basically doing a bash call. Bash call Rote blah 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 intent of what it's trying to do. As a response, it's going to get back these at symbols. And the agent has been instructed of how to interpret these, but we, as the CLI itself, does not depend on the at symbols for generating the code at the very end. It is just guidance for the agent of how to properly interpret the output.
Yeah, and my second question is, so if we install it, are we installing something that's like, we can see the source code for it, or is it like a closed binary that we'll download and use?
Sadly, it's the latter for now. We're trying to get people's opinion on the tool before we open source it. It's something that we're looking into. But right now it's proprietary.
Can I also have like branches in the workflow, like if conditions or?
Yes, you can. Yeah.
Thank you.
Hello, nice talk. What about non-deterministic things? So if there is, because your example is quite deterministic, so we can, for example, say to the cloud, let's make a program which is doing that. So how it differs, how it handles that types of problems?
Yeah, so our tool is essentially a sophisticated workflow builder. So generally, if it is a deterministic thing that can be achieved, it's going to excel at it. We have on our radar of how to add non-determinism in there. Right now, current approaches that we've experimented with is because we support shell calls, technically it can be a deterministic step to call Claude code programmatically with the prompt and get the output back that you can then parse, right? So essentially the generated code becomes a harness on top of Claude code. So that is an approach that can work for adding determinism, non-determinism, right? Interpret these weather results, and if it is sunny, then send a Telegram message to me, right? That can be done, although our skills and guidance right now are not optimized for it. So we have not explored this like very deeply.
Okay, thank you.
Hi, thanks for the presentation. You know, when you were speaking about the particular AI models, and you very nicely advertised the latest model about its focus on going for the target, did you experiment with setting the workflows of few agents to make one agent control another, and do you have some experience which models work with each other more efficiently than others? Like some maybe are better in controlling and others, and some are just accepting the feedback in a more efficient way. Thank you.
Yeah, so we're like running both our own experiments of like how different models like use Rote, and we try to gather data and statistics on that from our evaluation harnesses. But we also try to switch up and play around with all of the models, so and seeing how they behave. Right now, personally, what I'm doing is I'm running a Kimi model, Kimi K3, as kind of my main, let's say, orchestrator or thinker agent, because I really like the output of how it thinks about stuff. And then I ask it to create sub-agents using 5.6 Sol for doing the actual implementation work. Because I found that 5.6 Sol is extremely well at following a task and producing high quality results. But after producing like a lot of slop with it, I also don't trust it to own like large scale engineering efforts and orchestration efforts. We also use Fable and Opus 5 that was released recently. Those models are like extremely great for this orchestration layer, but because I mainly use the Pi harness, Claude code does not work well with third-party tools. So I usually just like whip out Claude code if I have something that I just want to play around with. Yeah,
limiting the output of the agents currently is the highest art of fighting spam.
yeah.
Quite interesting project, but there's one thing I wonder with what has been said before, that this is mostly for deterministic workflows, and what you said before that the generated binary, the TypeScript script is inference free. I wonder where is the difference between the Rote and the whole workflow here building this binary and just telling Claude, write me a TypeScript script of doing that? Like, where's the difference? What's the added value of Rote over just telling the agent to generate me a script that does the exact same thing?
Mm-hmm. Yeah, so there are like two answers to this question. First one is that when we are generating code from whatever the tool was used to achieve, we are basing this from the agent traces, and those become as fundamental building blocks. So as an example, you're asking your agent to, let's take the same GitHub thing, fetch some stuff from GitHub, look at the PRs and so on and so forth. It is going to stumble around, and it is going to take its time to achieve the desired goal. And then when we generate the DAG, we look at all the failed steps and we just drop them completely, right? So essentially, this DAG itself becomes proof that this task is achievable, and there is no actual code that needs to be generated at the end there, because like we can generate it from these steps and figure out like how they all intervene. When you ask your agent to produce the code, just like, hey, write me a TypeScript file that is going to communicate with GitHub and all of these other things, you become a software engineer at that point. And you need to understand, like, will this code do what I actually asked it to do? Will it not contain any extra unnecessary steps that are not part of the needed result? So we basically...
What if I tell the agent, like, do this action, like, perform this thing, and it performs it, and then I tell him, now convert it into a script?
If your context allows, then yeah, you can do that. Like, nowadays, like, if you're using, like, let's say Codex 200K context window, and you give it like a short enough task of like, hey, do this and that, and then write me TypeScript code at the end, yeah, it's going to do it. But if your workflow actually spans like something over the compaction boundary, then you're done, you're cooked. There's nothing you can do because the agent will not remember what it did previously because it's over the compaction boundary. With our tool, we capture all the traces, so when the code is about to be generated, we generate from the traces that were from across the previous sessions. So very large and sophisticated workflows actually survive compaction boundaries.
Okay, thank you.
Do we have any other questions? Okay, Robert's Pumpurs, everybody. Big applause. So thank you again, awesome presentation. And as you can guess by the smell of it, the pizza is here.